chemical reactions. Our object was to identify the polyatomic and spectator ions, predict the products of the chemical reaction, which were double displacement, and understand the importance of parameters of a reaction, and to explore the effect of catalysts in a reaction. There were 5 experiments. 4 of them were double displacement, and 1 of them was a catalyzed reaction. So each of these reactions will be explained and analyzed.
Okay, so as she said, there were 5 experiments to do. For the first one, before we even started, we had to prepare a 50 milliliter solution of 1 molar of CaCl2 and another 50 milliliter solution of NaOH. And at the same time, other groups were preparing solutions of NaCl and hydrochloric acid, which we would be using. And for the first experiment, 3 milliliters of 1 molar NaCl was added to 1 milliliter of silver nitrate, and the reaction was observed and recorded in our tables. For the second experiment, 1 molar of CaCl2 was added to aluminum sulfate, and the reaction was also observed. And then a small sample of calcium carbonate was added to hydrochloric acid, and the reaction was observed and recorded. And for the last double displacement reaction, 2 drops of phenolphthalein was added to NaOH, and hydrochloric acid was slowly added until the color changed, and a reaction was observed.
For the second part of the experiment was the catalyzed reaction. We used a 100 milliliter beaker. 50 milliliters of sodium potassium tartrate solution was prepared, and we added 10 milliliters of 6% hydrogen peroxide into that and mixed it, and the results of the solution were observed and recorded. Next, the beaker was heated on a hot plate to 70 degrees Celsius, and then once it hit 70 degrees Celsius, the reaction was observed again, and the results were recorded. Then we removed it, and we added 1 milliliter of cobalt chloride, which was the catalyst, and the results were recorded again. So this is our sample calculation. First we had to find how many grams of calcium chloride we would need. So you know the molarity and the liters. You convert 50 milliliters to liters, which is 0.05 liters. So then you use your molarity is equal to how many numbers of moles of calcium chloride over 0.05 liters, and then you get 0.05 moles. You then convert that to grams of calcium chloride, and that's how many we had to measure out for the solution. The second sample calculation, we had to find the volume needed of NaOH to make a 1 molar solution, 50 milliliters of a 1 molar solution. So we used M1V1 equals M2V2. The molarity of the stock solution was used to find the volume that was needed compared to the molarity we needed and the volume we needed. And we found it was 10 milliliters of NaOH.
Okay, and for our results, for the first experiment, which was sodium chloride and silver nitrate, they were both clear aqueous solutions to begin with, and when they were added together, this is what we got. And it was a milky solution, and you can't really see it, but there were small precipitate at the floating area.
The next reaction was aluminum sulfate and calcium chloride. Both were clear aqueous solutions before, and when the phenolphthalein was added, it was a bright pink. When the acid was added, the solution slowly turns back to clear, and this is how we know a reaction occurred. This is before the phenolphthalein was added.
For the next one, with calcium carbonate and hydrochloric acid, calcium carbonate is the white powder, and hydrochloric acid was a clear aqueous solution. And when they were added together, the solid kind of went to the bottom, and you can kind of see the solid down here, the liquid at the top. So it's just deposited at the bottom with a liquid on top.
The next reaction was sodium hydroxide and hydrochloric acid. This was, both were clear solutions before, and then when we added phenolphthalein to it, it turned the solution a slight pink color. This is kind of after the solution had sat for a little bit, and then once we added the hydrochloric acid, it turned back to the clear color of the original solution.
Okay, and this is for the second part with the catalyzed reaction. This was with peroxide and sodium potassium tartrate. The peroxide was a clear aqueous solution, and so was the sodium potassium tartrate. And the cobalt chloride was pink aqueous solution. The peroxide and sodium potassium tartrate without the catalyst was boiled, and there was no evidence of a reaction besides that it was just hot and boiling at 70 degrees. The color didn't change at all. And after adding the cobalt chloride, it kind of turned greenish brownish at the top and the mixture bubbled. And it faded away with time, which is why our picture wasn't exactly what we explained it was, because we didn't really catch it in time. So yeah.
In our discussion, they asked what happened when a catalyst was added, and we observed that the reaction rate was increased due to the immediate color change when the catalyst was added. The evidence that the catalyst was participating in the reaction was shown again by the immediate color change when it was added to the reaction. And the evidence that the catalyst was not consumed by the reaction is shown by the precipitate. So when the catalyst was added, there was a precipitate in some of the solution. And those are our